Reason Audio Basics 2. Let's get into it. Hey, what's up? My name is DigiKeys, and today we're going to be talking about audio and reason, specifically sample rate, bit depth, and latency. So let's get started. So let's talk about sample rate. What is sample rate? So for digital audio, the systems encode, store, and generate audio by taking quick snapshots of the amplitude of the audio. And so the speed at which the samples are recorded is what is known as the sampling rate. So the sampling rate is measured in hertz, which is the number of cycles or samples per second. The most common sample rates are 44.1, 48, 88.2, and 96 kilohertz. So the sampling rate determines the highest frequency that can be accurately represented in a digital audio system. Speaking of the highest frequency that can be accurately represented is called the Nyquist frequency. And to know what this frequency is, you have to do sampling rate divided by 2. So for example, the range of human hearing is 20 hertz to 20,000 kilohertz. So the minimum sample rate you should be using is 44.1 kilohertz. So then we would do 44,100 divided by 2. So that will equal the 22,050 kilohertz. So Reason allows you to record or import audio of any sample rate. So if you did a recording and your sample rate is different than the rate on the audio card, then Reason will do a sample rate conversion automatically. So let's talk about bit depth. So bit depth determines the number of amplitudes that can be represented in our system. Or in other words, bit depth determines dynamic range. And dynamic range is the difference between the quietest sound and the loudest sound as we can perceive. So the higher the bit depth, the higher the dynamic range will be. So let's talk about latency. So for our computers, there's a delay between the time we input a sound, we tell the hardware to play it, and from when we can actually hear it. So that delay is referred to as latency. So audio applications receive and generate their audio in portions. And so those portions are then passed on to the audio card in which they're temporarily stored. And that place where they're temporarily stored is called buffers. So depending on your buffer size setting, you're either going to be increasing or decreasing latency. So a small buffer size setting reduces latency. It does, however, increases the digital signal processing load, and too small of a buffer can actually cause issues such as crackling and distortion. So a large buffer size does reduce the digital signal processing load and the audio quality is good, but as you increase the buffer size, the latency also increases. But that's it for this video. Thank you for watching. I hope that was informative. I just wanted to give you a basic understanding of those 3 topics. So like, subscribe, hit that notification bell, and I'll catch you next week.